Hello everybody. So I'm Gianpiero Napoli. I'm going to be talking about publish subscribe. I hope it's interesting for you guys because so far what I've been doing is convincing people in my company that it was great, and now it's a different audience. So I'm trying to present to you guys why we decided to use Lua to do what we do, that is pub sub. Yeah. Sorry. What I'm going to be talking about is who I am and what my company, real-time relation, or my company like us to RTI, does, and how we use Lua to simplify the APIs that we have and to add scripting capabilities. And then I have a couple of demos. I mean, half an hour is not too much, so I hope I can get there. I don't have one. So I can tell you, like in languages, it's important to say what I am not. So I'm not a Lua expert. I use Lua mostly for the C API to integrate with our product. But by any means, I'm already a Lua developer. So what do we do? So we are a middleware company. We create a piece of software that you put in your application and the network stack and the operating system to do basically pub sub, real-time pub sub. So DDS sounds like the dentist. We are not dentists, but it's a standard, but OMG, for who knows, is the organization that standardized Forba. One of the standards DDS. I think they also do UML and stuff like that. So it's really like a collection of standards. DDS is the API that allows you to do pub sub, but also there is another standard that is RTPS, that is the network standard, how you encode the data that you're sending, and what is the interaction between the protocols and the format that goes on the wire. And then there are extension how to describe your types and how to do security. So the basic is you can think pub sub. I mean, maybe everybody's familiar, but just to set the stage, you have one publisher or a bunch of publishers that publish some information over the network, and then other applications, the subscribers that are interested to that topic are going to subscribe to that topic and get the data. The nice part about DDS is that discovery is automatic. We do type matching, so the topic has to match, but also the type of information, data that you're sending has to match. And also, very important, the QoS. You can set QoS in the publisher, quality of services, and the publisher and the subscriber, and they have to match. Otherwise the two entities are not going to talk to each other. So the simple example is that you have temperature riders in a nuclear facility or something, publishing temperature, pressure, and stuff like that. And you can think of this publisher populating a global data space where all the subscribers can access and read those data at their own speed. You can have time filter. You can also set up filtering, like I want to read the temperature only if the value is more than 100 Fahrenheit or stuff like that. So it's very good to have different kind of application doing different things with the data. For example, an alarm, you want to be sure that you're reading all the temperature that is being published. But if you have a UI, for management, probably you don't care to read every single sample. You can get a sample every half an hour, and you can send the filter from the subscriber to the publisher, and the publisher will send the data on the wire only when it's necessary. So you reduce the bandwidth that you're using. Yeah, so I mean, I guess you can think it as a database in the cloud that everybody can access. The nice part is the peer-to-peer, so there are no servers involved. Like if you know MQTT or stuff like that, they have a broker. Here, each application, a publisher or a subscriber, they have a local cache that represents the state of the system. And discovery is automatic if you are multicast. So you can set up a list of peers to reach, or you can have a discovery service if you really want when you're like dealing with stuff like Amazon Cloud or things like that. Anyway, so The entities that you have to create when you start programming with DDS are basically a domain participant that represents like a logical space. It's usually contains one or more subscriber or one or more publisher, and each subscriber has a data writer, and each publisher can have data readers and so on. The way a data writer and a data reader match is based on two things. One is the topic, so for example, topic temperature or topic pressure, they are two different topics. But also on the data type, for example, if you have you're trying to communicate a position, you can have X and Y, for example, or if it's in 3D, you have a Z as well. And if they don't match, if they're not the same, if the type are not the same, they're not gonna match. So you can have this kind of matching. But I mean, I think what I want to say here is that if you're programming this in a language like C or C++ or Java or Ada, we support a lot of them, you have to write a lot of code before you are able to actually start writing your data. You have to create a domain participant. The domain participant is a factory, so you can ask, hey, give me a subscriber, and then when you have a subscriber, you can create a data reader. So and you also have to register the type and the topic, so there is a lot of boiler code that you have to write before you're able to start sending data. And Lua kind of solved that problem for us, or addressed that problem. Another important thing from our middleware is that you can set quality of services. So after you write the code, you can configure your entities, your data readers or data writer with different quality of services. And there are a lot of them. These are just a few of them. For example, you can set if you want to send the data reliably or not. So the transport is by default UDP. You can pick TCP, or there are many transport even for satellite communication when you have a lot of delay. But let's say that you're using UDP, right? Sometimes it's important to be sure that the data are delivered. Sometimes it's not, right? And of course that comes with performance. So if you're using, if you're sending a temperature every second, what is important for who is receiving the temperature is the temperature right now. So if you miss a sample, that's no big deal, right? So you may want to go with best effort. But sometimes it's important that you don't miss any sample. For example, if you're calculating an average of that temperature, you want to be sure that you get all of them, right? So you can set that in the QSs. And you also have things like history and durability. So for example, if you're publishing some data and the data reader is not there at that moment, but it comes into the system later, that's what we call a late joiner. You may want to be able to receive all the previous data even when you were not there, right? For example, the connection can drop, and you want to be sure that the data are kept for you. Well, then in that case you use durability and history. And another one, important one, is liveliness. So you can, when you are in a complicated network situation, when it's not very reliable, you want to be sure that when a data writer goes away, you know that went away, so you can maybe start another one, or you can back it up and stuff like that. So liveliness is another QS that you can say, you can set, like a timeout. After I don't see any, you don't have to rely on the data coming from that entity, but it's kind of sending to an heartbeat. You can set up that through QSs. Anyway, going to what we did with Lua, right? So I think everything happened. We have a product in RTI. We call it the routing service. That what it allows the user to create. Basically, I don't know if you're familiar with Apache Camel, but basically you can create readers and writers and get data, transform them, and send them in a different message. Or you can get data from different sources, mix them together, and then send them as one, right? Like a combination of the two. When somebody else in the company was presenting that, we were trying to publish shapes, so X, Y, and a color, and then switch. Basically, we were getting X and Y, and then publish another shape that will have X and Y inverted. And that was like, 300 lines of code. So we were, okay, I think it's not very nice, right? So when we got out of the meeting, me and Rajita, is going to be talking tomorrow, here is from RTI as well, we decided, we bought new Lua for personal interest, and we decided to try to use Lua as a language to make that kind of interaction easier and shorter. So the way you usually program DDS is like you define your type, data centric. So the first things you do is you define your type, right? For example, your position has an ID, your airplane in the air, and it has X and Y, right? Then you generate some code that, whatever language you want is gonna generate code for serialization, visualization, all this stuff, sending and receiving the data. And you can define your QoS in XML. So that's very cumbersome. You have to do a lot of stuff, a lot of code just to start writing X and Y, right? So we introduced something called the Lua connector. That is much simpler because all you do is you have the Lua interpreter, we also did the embedding part. So we embedded Lua in our product, so now you can run something that we call the prototyper that has a Lua interpreter inside and execute the Lua script. And basically all your entities are defined in XML, and it really becomes not too much code. So we simplify the hundreds of API that we have with DDS with three simple concepts. One is the connector itself. The domain participant, we saw it before, so the connector is a wrapper around the domain participant. I call it a domain participant plus because there's other stuff in it. Then there is an output data port and an input data port. And the operation that you can do on those ports are just, for example, on the output you can write, dispose, and register. These are concepts that if you're familiar with DDS you will get. The point is not to become expert of DDS, but see how we use Lua. So you can basically, on an output port, you can set an instance, a sample, and then you can write it. And on an input port, you can read or take that sample and then do whatever you want, access the field that are in the sample. So the reason why we picked Lua, well, we wanted some solution to do scripting. Lua is embeddable, it runs on all the 75 architecture we support. We support embedded systems, so a lot of architecture. We needed something that we run everywhere, and Lua was really there. I guess the only solution. And also we wanted to simplify the API of our product using the table concept that Lua gives you. Everything is a table. We extended that. We use the meta table to call function underneath when we are setting a value. So that was pretty nice. And we were able to reduce boilerplate code, and our customers are using the lobby mostly to implement tests or to demonstrate the value of our product using Lua, because it's much easier to script and prototype a demo for whoever decides to buy the product. So we actually started by embedding Lua in our prototyper, that basically is just giving you the main loop. All it's doing is like waiting for a period to expire and then calling the Lua script, or waiting for data to come in and then call the script. So basically, the prototyper is the main loop, and call the Lua, execute the Lua script only when it starts, when it stops the tool, when there are data available, and when a timer expires, you can set on the command line, right? And then we saw that a lot of people wanted to use it inside the Lua interpreter, with the standard Lua interpreter, so they can easily link with other libraries and stuff like that. So we extended basically, we took the library that we wrote that is embedded in prototyper and make it a little bit more usable as Lua in the Lua interpreter. But it doesn't change much. I don't know if you guys can see it, but basically this is how. Now you don't have the reference, but it used to be like hundreds of lines of code in C or in C++. But in Lua, basically what we did is like, well, if you're running in the Lua interpreter, you have to do number one, that is like creating a new connector. And basically what you do, you pass the XML file that defines all your data readers and data writers. And an XML file can contain multiple configurations, so you also have to say which configuration you want to use. Once you do that, you have the connector. From the connector, well, there is a table of writers and of course a table of readers that you can iterate through it, but you can access also by name. So you access now the writer that you define in the XML. And now that you have a reference to the writer, you can just set the message that is in there using this, what Lua, the natural way to set stuff into a table with Lua. What it is going on underneath is that when you do this assignment, we call an internal function of our middleware that creates a sample for you, it sets that field, and of course this is just one field, but you can have very complex structure. You can have a structure that contains another structure, that contains a long, and all you have to do that is set, food.bar.x, and you can set that, right? And the only problem there is that it's a string, so you can make mistakes there. But we kind of address that with another piece of Lua code that we call dynamic something language that Rashid is going to talk about it tomorrow. But basically, the concept is very simple. Instead of passing a string there, you, at the beginning, when you load XML, we also create a table called types for you. And types will contain a table called foo, and a table foo will contain another table called bar, and another table called x. And when you do foo.bar.x, it will return to you the string foo.bar.x. In that way, basically, you, if you have like a smart editor, you can have auto completion and stuff like that. So, whatever, once you set the instance, all the fields in your instance, in this case there is only one, you're just going to call write. And that will basically write the sample using DDS for you. So 2 or 4 lines of code, 3 or 4 lines of code instead of hundreds. And then the subscriber is pretty much the same. You create the connector again in a different file. You get the reader all that way. You do a take, and then the take automatically fill a table of samples you can have, because a single take can give you multiple samples, and then you just iterate through that table and you bring the message. Yeah, I guess I want to show you the code and run it for you to have an idea of what's going on. And I'm going to do it with the embedded version of the tool, that is prototyper. So let's look at the, maybe first we should add it to the XML very quickly. So here we are defining the types. So the type is a structure called shape type that has a color, an X, a Y, and a size of the shape. You can have very complex structure here, structure of union, or with the numerator and stuff like that. But for the example, I thought it was easy to use just a simple shape. And then what you define here is the domain. So basically what I'm saying is that I'm registering a type called shape type, and 3 topics, square, circle, and triangle. And then I have 2 participants. One is called shape publisher, that basically has a bunch of values which Lua script you have to run. You can also override that with a command line, but you can configure with XML. And then he has 3 publishers, 3 data writers, sorry. One is the square writer that publishes a square on the square topic, and then the circle writer, and then the triangle writer. And then we have another configuration that you can know, that is the shape subscriber, that of course is going to run the shape subscriber.lua script. And that has that's 3 data layers, a square, a circle, and a triangle. So now that we know that, we have 2 systems. One has readers and the other one has writers. These are the scripts that I'm going to run, right? So the subscriber here is very simple. So remember, we are running this in prototype, so we don't have to get the connector. The connector is given to you, is instantiated by the prototyper. All you have to do is to access it. And so basically what we're doing here, we are doing a for loop, basically, on all the readers that are contained in that container. Every time we take one, we do a take. The take can return you 1 or more sample, because you can wait 10 minutes, and the middleware will receive all the data, and then whenever you access them, it's up to you, right? So you're going to get an array of sample, and what we do is we iterate through the array, and for each one of them, we check that it's valid data, because it would be, this is a DDS concept, it would be just a dispose or unregistered, but whatever, if the data is correct, what we do, we just access each single field that we print on the screen, right? So nothing special. And then the publisher on the other side is similar. Let's look only on one of the writer. We basically access here the table of writers, and we get the simple writer. And then once we have it, we retrieve the instance that is allocated for you in C, down into the library, and we set each value to the color, the X, the Y, and the shape size, and then we write. And I think we do that a bunch of times in a for loop. So, sorry, the for loop is provided by the prototyper. The prototyper, every second will execute this script. So that's the main loop. So let me run it. So when I start prototyper, it's going to detect that XML file exists because it's called user QS profile, and of course we have parameter, you can pass whatever file you want. And it detects that there are two configurations. One is the publisher and one is the subscriber. And the XML file will also specify which Lua file you have to execute, right? So I'm going to say start publishing. It doesn't print anything on the screen. And then here I'm going to say start subscribing. And it's receiving the data, whatever, random data. And of course, I don't know if you noticed, but we didn't set up any name. It's a discovery to go to multicast the discovery shot, exchange the type information, match, and then they start communicating. And of course, now you can start from any subscriber as you want, right? So if here I start another subscriber, I should be receiving the data. So you can have many of these on different computers, of course, and this is on my machine. So this is the basic pub sub that you can do with DDS, right? And then with Lua now. Okay, so almost done with my time, but I want to show you a bunch of QSs. So one of the reasons why we decided also to use Lua inside prototyper is because you can dynamically change the Lua code, and when the file, we wrote in prototyper basically check if the file changed in the last I don't remember, 5 seconds or something, and if so, reload the code, and you have the new code updated, right? That's pretty cool. I mean, the people really like that. So I have here a little GUI application, and I'm gonna subscribe to triangle. So instead of the shape, there is one topic called triangle, and I'm gonna set a history that is a QS that says, okay, keep the last X sample, okay, that are coming. So I'm gonna set that to 500. Okay, nobody now is publishing, but here I have basically another Lua script that is gonna be publishing data with a period of 0.01 second. And of course it's not working. Yeah, I know. But anyway, the nice part of this was we had basically a mathematical function that was going to paint a little flower using shapes there. And then what I was going to show is that changing one of the parameters, the shape of the flower will change. For some reason. So we also have filtering that we can enable just the same code that I showed you before to publish and subscribe. You could enable filtering, for example, durability. And what will happen is that without changing any Lua code or any code in general, if your reader comes later into the game, starts later, it will receive all the data that the writer has been writing. And actually, if you enable another component that is we call it persistent service, even if the data writer goes away, the data are still available in the system for late joiner to come back and receive the data. And of course, content filters, you can have expression like, if X is bigger than 50, they receive the data. And the nice part is that they're not sent on the wire. So it's not something that's done on the reader side, but it's done on the writer side. So for us, in general, using Lua, I'm pretty much done. My goal with this presentation is that if you have any need of doing publish, subscribe in your Lua application, you will have a look to what we did. But for us, really, using Lua was a game changer because then based on this library that we wrote in Lua, We presented it and people really like it, but then of course, you know, people goes like, why do you support Python? Why don't you support Node.js, right? And well, I mean, I went back to my desk and I said, well, I mean, I have this library that is using C and Lua, and now I can use FL5 to basically get these few API that are in Lua and interface them with JavaScript and Python. So with very little work, we were able to create, next to the Lua connector, we were able to create the Node connector and the Python connector that in reality underneath they're using Lua. So that was fortunate. And we had the same, you know, when we started, we had decided not to use Lua, you know, the way with the HC API or to go with the FL5 way. And we decided to use Lua to embed it into the prototyper. Probably if you were going to do just the one interpreter things, maybe FL5 would probably be easier to do. But yeah. So, I mean, that's pretty much it. So if you have any question, you can email me. I put some reference there with the link where you can download the prototyper with Lua and play with it. And also we have a forum where, you know, if you have any question, you can just write there, and most likely me, if they're about Lua, I'm going to answer. And well, they forced me to put my things we are hiding, so have a look to the career page. That's it. Questions?
What is the licensing on your product? Is there...
Right. So I'm an engineer, so it's not free. It's not open source or anything. But we have licenses that you can start with for free. So you can download the product, and it comes with a 60 days license. So you should be able to evaluate. We also have you know, university programs. So if you are in college and you want to use our software, it's basically free. You just have to mail us. And we do that. And the connector in general, JavaScript and Python and Lua, you can use it for free. It's on GitHub, not the prototype, but the Lua only one is on GitHub, and you can use it.
Will you be publishing your slides?
So maybe I'm going to tweet with the link to the slides, or I don't know if we have a plan for the conference to publish all the slides together, but yeah, definitely. No question?
You are using XML for config, but since Lua can also be accessed as a config file, what if you try to do a lot of things? What if you turn the config XML to a Lua file?
Actually, that's a very good question, and we tried it. I don't personally like XML. I would do everything in Lua, but our customer uses XML. It's used by all the other languages, C, C++, and Java. So we kept that. For one of the projects that we did, we actually parsed XML file into Lua. But yeah, I mean, it's our question. But I think it's the compatibility between languages, I guess. Any more questions?